So, welcome everyone to this lecture. This is revision lecture number 3, and in this, we are again going to solve some papers as we have already done. We'll start with the paper of 25th of Jan, shift 2, and let us begin by solving it. Let me take you to the first question. And this is the first question for you. A wire with resistance 5 ohms is redrawn to increase its length 5 times. What is the final resistance of the wire? I'll give you a minute to give me the answer. We have done a lot of questions of this type. Still, don't remember how to do this. Remember, the only thing you have to remember is to remember things. The only thing you have to forget is the habit of forgetting things. That is going to be. Let's hope that you can recollect. Length has been increased 5 times. I also given you the formula for that. Resistance rho L by A. If length increases 5 times, so what will happen to the resistance? It will increase how many times? New resistance R dash becomes rho remains same. L dash. How much is L dash?
25 felder.
How much is L dash?
5 times, sir.
Divided by. Does the area remain same?
No.
Forget simple things in life. Nothing is going to get you into an IIT. Rho L by A, length has become 5 times, area has become 1 by 5 times, so it will be 25 times of the original resistance. Original resistance is 5 ohms, so the answer is 125 ohms. We've done a lot of questions on this. Go back, see them. That is the only thing I can ask you, though. It's too late to do anything else. Anyways, keeping the disappointment on one side, let's see if you can do this question correctly. The velocity of a particle, the position of a particle is given. You have to just find out the velocity. This is as simple as it gets. What is the answer for this one?
Option 1, sir.
Option 1. See, God exists. So if you just keep doing the simple things correctly, velocity is nothing but the derivative of position. You differentiate it once, you will get 4t. You put t as 2. You don't have to even use your copy and pen, and you will end up with 8 meter per second. That takes us to the third question. Same paper, and it comes on your screen now. A particle performing SHM with amplitude A starts from x is equal to 0 and x is equal to a by 2 in 2 seconds. Find the time required by it to go from a by 2 to a. So it takes 2 seconds to go from x is equal to 0 to x is equal to a by 2. The simplest equation that you can use is x is equal to a sine omega t. The value of x is given as a by 2 is equal to a sine omega t. From here, you will get the value of omega t as pi by 6. Time is given as 2 seconds. So your omega becomes pi by 12. Now your omega is pi by 12. Your time period becomes 2 pi by omega. So your time period becomes 6 seconds. The total time is 6 seconds. Then you just draw a simple sine wave from 0 to a by 2. From 0 to a by 2. This is a by 2. This is a. Now, how much you are going to get? From 0 to, we have found out the time period. How much is the time period? Have
2,
I
sir.
done it wrongly? 2 pi by omega, 6 seconds. 2 pi. I think it is 24 seconds, not 6. I think I've done a mistake here. Time period is 24 seconds. Is that so? 2 pi by omega. Time
Yes.
period is 2 pi divided by omega. I always make mistakes in ratios. This is 24. From here to here, it takes 24. So from here to here, it will take 12. So from here to here, it will take 6. Out of this 6, 2 has been taken from here, 0 to a by 2. So what is left is 6 minus 2. So the answer is 4 seconds. And when we are doing this topic on SHM, I had given you a lot of problems on this. Please go back and have a look at those problems. You may not find the exact same problem, but you will find the same problem in different ways. So please mark this question, go back and have a look. I have to move ahead though. And this is the next question. A body of mass m is placed at a height re from the surface of Earth. Find the increase in potential energy if the height is increased to 2r from the surface of the Earth. So how are we supposed to do this when it is at a height of r from the surface of Earth? Potential energy in the first case is minus, I am writing m, minus g capital M small m by 2r. When the height is raised to 2 times r, it becomes minus gmm by 3r. The change in potential energy you can find out, subtract, and you will get the answer as 1 by 6. Gm by r can be written as mg into r. I hope you know this. G capital M by r is capital G M by r can be written as small g into r. We have seen that, yes or no? So the
Yes.
answer that you are going to get will be this one. Okay. So I think you are doing good in this. You don't have to have a look at this. Remember, whatever mistakes you are making, you go back home and try questions from that particular section. You already have everything that you need. You also have recorded lectures. This is the next one. A charge of 10 microcoulomb is placed at the origin. Where should a charge of 40 microcoulomb be placed on the x-axis such that the electric field is 0 at x is equal to 2? So how are we supposed to solve this? This is the easiest question that you can probably get. Your origin is here. Your 10 microcoulomb charge is placed over here at x is equal to 2. So this is 2. Electric field has to be 0. Let me put a charge of 40 microcoulomb here at a distance of x from the origin. You have to find out this value of x. Electric field has to be 0. Electric field created by this 10 microcoulomb charge will be k into 10 divided by 2 square. The electric field created by the other charge will be k into 40 divided by x minus 2 whole square. I guess you can solve this. And the answer that you are going to get after solving is x is equal to 6. And that is the answer, my dear friends. Let us move ahead. You have noted this down? Look at where you are making mistakes. And please don't make these mistakes in the examination hall. Here you can make mistakes and go away with them. In the examination hall, if you make the mistake, well, the question is gone forever. Anyways, that takes us to the next question. This is the next question. I'll give you 2 minutes to solve this. Something is given, and then something is asked. I hope you understand this question. I don't want to waste the time by reading this. Option 4. The diagram shows different transition of electron A, B, C, D between energy levels with energy mentioned among them. Which transition will generate a photon of 124.1? You understand that the energy difference will be equal to hc by lambda. H into C can be written as 12,400 or 12,000 or 1240 nanometers. So you just have to find out what should be the energy difference. So I can write it as 1241 or 1240 divided by 124.1. So I will have approximately 10 electron volts. The energy difference has to be 10 electron volts, which is only available between 0 to 10. That is transition D. And that, my dear friends, is your answer. We understand this?
Yes, sir.
Okay. Well done. If you could do this, remember the question that you are making a mistake, you must go back and solve more question on that topic just to be sure that you don't make a mistake there. Remember, the only place where you can do mistake is in your calculations, which are not up to the mark. I must say that. And in not remembering simple things. So what I'll suggest is you still have time. You can go through the entire course in one day, just noting the simple points, simple things that I had given you. You had marked them. Just make a quick revision of that, and I think you would be good enough. As you can see, questions are pretty straightforward and pretty simple. This is the next one, and I'll give you 2 minutes to give me the answer. So, because of this wire, what will be the direction of field?
Inside, sir.
Inside. Because of this wire, what will be the direction of field?
Inside.
Both the fields are going to get added up. So the answer is B is equal to mu naught by infinite wires 2 pi into R into I1 plus I2. And again, this is what I can do. After that, you just have to put the values, get the answer. And what value are you getting, beta?
Option 16 into 10 power of minus 5.
16 into 10 to the power minus 5. The answer that is given to me is option 1. And I hope that you get this answer. As I said, your calculations are the one that is going to get you in deep trouble. Won't say anything apart from that. I don't know how do you calculate, but you always seem to come up with wrong answers in calculations. Anyways, this is the next one. LCR circuit, XL is this, XC is this, power factor is how much? Option 2, chalo, we got at least this one correct. So to how to get the power factor, cos of phi is R by Z. Here R is given as 80, Z is under root of XL minus XC. So XL minus XC is 50 square plus 80 square. Whatever you get is the answer. And this time, thank God, your calculations are also good. And this is the answer for this one. That takes us to the next question in the line. Why is not coming? And this is the next one, and I'll give you 2 minutes to give me the answer for this one. 5 by 7 is correct. This is a disk. What is the moment of inertia of this disk about this axis?
5 by 4 mr square.
5 by 4 mr square. Solid sphere about this axis?
7 by 5 mr square.
You just divide it, you get your answers, and you stay happy. Do you understand this?
Yes.
Then, my dear friends, this is the next one that you are going to do. I'll give you 2 minutes. We have done a million of questions on this pattern. Best of luck. This is a straightforward question. Complementary angles, the range is same. Yes or no?
Yes, sir.
Chalo. Good. Then comes this one again. As you must realize, we are doing questions from the session that got over, and you will not find a single question that we had not discussed in the class. This is the next one. Again, I'm repeating myself. We had done a lot of questions on this category. Give you a minute to solve this. It has one additional vibrational mode. I think you have skipped this. So the degrees of freedom 5 plus 2, it will become 7, and therefore the value of CV is 7 by 2R. Go back and have a look at what we had discussed. Obviously, you have forgotten it. Go back and have a look. What happens when the molecules start to vibrate for one vibration on one axis, 2 degrees of freedom are added. Which is vibrating on one axis, 2 degrees of freedom are added. Total number of degrees of freedom becomes 7, and hence the answer is 7 by 2R. This is the next question. I'll give you a minute to solve this. Now remember, if this such a question comes, it might require some time for you to solve it, because you have to deal with two cases here. First is the pink case where you are trying to push it up. What will be the minimum force required to push it up?
mg
What is,
root 2 plus mu mg by root 2.
how much?
mg by root 2 plus mu mg by root 2.
Mg by root 2, which is downwards, plus mu mg by root 2, which is upwards. Yes or no? Which is also downwards. Yes or no?
Yes, sir.
What about the force, minimum force, which is required to push it downwards?
Mu mg by root 2.
Deep breaths you need to take. Deep breaths. Deep breaths. You're pushing it downwards. Weight ka component is also downwards. So F down plus mg sine theta should be equal to mu mg cos theta. So the downward force will be mu mg by root 2 minus mg by root 2. Do we understand this? Do we understand this? This
Yes,
force
sir.
is 2 times this force. From there, you will get the value of mu. The value of mu that is given to me is 3. Do we understand this?
Yes, sir.
Simple things, and you make mistakes. Well, the only way you can eradicate those mistakes is by solving a lot of questions, and the only thing that you are lagging is practice and your calculations. So I'll keep on saying till my last breath. This is a question from my favorite topic. I give you a minute to give me the answer. You can see when there are no calculations, the answer come very fast. Option 2, I will not elaborate on this further because this is a question on units and dimension. If you don't know the units and dimension, there is no point of doing physics at all. Let me take you to the next question. Oops, what is happening here? Very smart question, and that might remind you of something that we have done in the class. This one, and I think I gave you everything in a tabular form. Same, even the order is different, but things are same. What is the answer for this one?
Option 3, sir.
Option 2. I will not elaborate much on this. You don't know what is Ampere's law. You don't know what is Gauss law. I have nothing for. I have nothing more to tell you. Let me move on to the next question. This is the next question. A stationary nucleus breaks into two daughter nucleus having velocities in the ratio. Find the radius of their nuclear size. If I remember correctly, we had done a question like this in the class. So it's given that their velocities are in the ratio 3 is to 2. So their masses will be in the ratio 2 is to 3. And the nuclear size is A naught into the radius cube root. Therefore, your answer will be 2 by 3 raised to the power of 1 by 3. I hope you understand this.
Yes, sir.
Thank God. The things that you remember. We have put in a lot of hard work, and I hope that you are going to get the reward of that hard work. This is the next question. What is the answer for this one?
Option 3, sir.
Chalo. Option 3, I will not say anything. But if you don't know these processes, well, not even God can help you. Okay, this is the last one, and this is from the second section where you have to give the answer in terms of decimals. A metal rod of length 1 m is moving perpendicularly to its length 8 meter per second. Magnetic field of 12 Tesla, 12 Tesla, 2 Tesla. Perpendicular to motion. What is the EMF involved between the two ends of the rod? And the answer is yes.
16, sir. 16 volt.
Answer is 16.00, and that is what we are looking at. Well, that brings us to an end of this class and this paper. As you can see, the paper was pretty balanced. It had some really simple question. The only question which would require some calculation or something was that question on friction. Apart from that, everything was straightforward. Units and dimension, one question was there. Electric current also one question was there, which we don't have time to solve. I will just show you that question. This is a question that you can easily solve by, do you remember that nodal theorem? Do you remember that nodal theorem I told you? Remember that? Anyways, you are supposed to find out the current, the ratio of current. I think this is a simple question which you can do by the nodal theorem. Do you remember that nodal theorem? So you can try this question at home and get the answer. We'll meet tomorrow and we will try to solve the next paper. Take care and may God bless you. Please work on your calculations. Please work on the topics that whose questions you have done wrongly. Just go through the basic formula. Just go through the lecture once all you once more. You have the recordings with you. Take care. Bye bye.